All right, so here we go with test your understandings. I didn't go through the stuff before because it was all in the videos, but please emphasize to your brain that inertia is not a force. Okay, it doesn't show up on free body diagram, anything like that. What does a scale actually measure? A scale measures the force it exerts on the object. When you step on a scale, the scale is pushing up on you with some amount of force, and that's what the reading will measure. A force sensor, a force measure, measures the force it exerts on an object, and the spring scale also measures the force it exerts on whatever it is that you have on the spring scale. All right, so test your understanding. 60 kilogram student stands on a scale in an elevator. What does the scale read if the elevator has an upward acceleration of 2 meters per second squared? Sounds familiar, doesn't it? Draw a free body diagram for the student, write a second law, and show the process of solving the equation. That's the important thing here. Showing this process. Yes, it's an easy question, but I want to make sure that you get everything correct. So we have our weight force going down, and we have the normal force going up. Notice my normal force is slightly larger than my weight force. Now I'm going to write my second law equation from this, and I'm going to say my net force is the stuff that makes it go, Fn, minus the stuff holding it back, Fw, equals mass times acceleration, my net acceleration. Stuff that makes it go. So we can now plug in our numbers here. We know the weight force is going to be 60 times 10, which is 600 newtons. So the normal force minus 600. Mass is 60 times 2, because the net acceleration is given to us as 2, so 60 times 2 is 120. Our normal force will then be 720 newtons. The unit for force is a newton. Kilogram times meter per second squared. There you go. Next up, 60 kilogram student stands in a 340 kilogram elevator. What is the tension in the cable supporting the elevator? All right, so we're going to do a free body diagram. We have a, what's the system? We have student elevator system. Okay, so we have the combined weight of the student and elevator, and then we have the tension pulling up the elevator. Downward acceleration, tension, and then our acceleration is going down, so we can see this as a longer arrow. Our weight is going down and the tension going up. Newton's second law equation, so the net force, stuff that makes it go minus the stuff holding it back, the weight is making it go, combined weight, remember, combined weight minus the stuff holding it back, that tension. What are we solving for? What is the tension? So we're solving for tension. Equals mass, total mass, times net acceleration. So the total weight force is 600, because 60 times 10. Mass times acceleration. Mass times acceleration. Times 10. So we have 3,400 plus 600, so that's 4,000 newtons, minus our tension force, equals total mass, 400, times our acceleration of 4, so we have 1,600. Subtracting 4,000 from each side, we have 16 minus 40, which is Ft, we're still negative Ft, equals 2,400 newtons. So Ft is going to be 2,400 newtons in the up direction. Up direction. You can have that positive, you can have it as negative. It is negative because up is the opposite of our net acceleration downwards.